Okay, so this is video on to be focused on enantiomers. Okay, we'll be focused on enantiomers. What are the requirements of enantiomers and how to draw enantiomers. Okay. So first, what are the requirements for enantiomers? Maybe we can recall that a requirement untuk molecule to form enantiomers. The first one adalah the molecule itself should contain chiral carbon. Maybe you can check on the notes what does chiral carbon means. So basically, chiral carbon can be simplified as carbon that is bonded to 4 different groups. Okay, so when I draw example, as I draw this structure, so this carbon here is classified as chiral carbon since it is bonded to 4 different groups, and P cannot be equal to Q, cannot be equal to R, and cannot be equal to S. So that what it means by cannot be bonded to 4 different groups. And another requirement for enantiomers is the molecule is not superimposed with its mirror image. Okay, the best analogy to describe this is your right hand and your left hand. It is side by side and it's actually mirror image to one another. But if you put your right hand on your left hand, it's actually won't exactly superimpose on each other. Maybe I will explain that better in class. Okay, or you can check on other videos on this analogy. Okay, I'm going to use example 1 for the structure of 2-butanol to explain on is 2-butanol can form enantiomers or not. Does it has chiral carbon or not? So first of all, this is the structure of 2-butanol with 4 carbon, and the second carbon is bonded to OH. So first, what you need to do, you better expand the structure. Okay, and I'm going to check on every carbon. Does it has chiral carbon? Okay, every carbon we have to check. So we first have to draw the expanded structure for CH3, CH2, CH3. So this is the expanded structure of this 2-butanol. Okay, the fourth carbon is bonded to H, H and H. Okay, I'm going to check on the first carbon. It is bonded to the same atom, H, H and H. So the first atom cannot be classified as chiral carbon. The second atom, instead, it is bonded to hydrogen, bonded to CH3. This is another group of atom. It is bonded to OH, another group of atom, another functional group. And this group has CH2 and CH3. It is also classified or considered as another group of atoms. So I can say that the second carbon is chiral carbon since it's bonded to 4 different groups of atoms. to 4 different atoms or 4 different group of atoms. Okay, so we have CH2 and CH3 here. Consider as another group. So now I'm going to draw structure of 2-butanol. But first I'm going to identify the first group there. So this first group is CH2 and CH3. Second group, I can draw hydrogen. Actually, the location of groups can be anywhere. So the third group is CH3. And another group can be OH. Okay, so this is the structure that shows that second carbon is the chiral carbon, and you have to draw the dotted line to draw its mirror image. So this mirror image, you just simply check on the first structure and you just draw its mirror image, pasangan image cermin dia. So you just have to draw exactly based on the first structure. Okay. The last one bonded to CH3. Okay, so I label here structure 1 and structure 2. So the relationship between structure 1 and structure 2 is actually they are enantiomers. Okay, so this is example 1 from the module using 2-butanol. Next, I'm going to explain on this. I'm going to answer this question. Which of the following compound can exhibit optically active? So first, I'm going to draw the expanded structure of structure A. Okay, to determine either the compound is optically active or not, you have to determine either there is any chiral carbon in the structure first. Okay, so when I expand it, I draw it in expanded structure, then I can identify it better. Either any carbon in this structure has chiral carbon. So the first structure, so the first carbon bonded to does not have chiral carbon. Okay, so the second structure also don't have chiral carbon since it only has 3 groups. Okay, so chiral carbon should have 4 groups bonded to it. The third carbon is the same. Okay, so it's not chiral carbon because it only has 3 groups. If you check on the fourth carbon, okay, fourth carbon also cannot form chiral carbon since it has 2 hydrogen atom as well as carbon number 3. So we can say that structure A cannot form enantiomers since it does not have any chiral carbon in the structure. And we can say that it is not optically active since the question asks either the compound can exhibit optically activity. Okay, for the structure B, if you check on carbon atoms for this structure. Let's say you check on the first carbon, is not kira carbon. Second carbon, yes. Third carbon not, and the fourth carbon also cannot form kira carbon. It does not have kira carbon. So since you have identified that second carbon can form, does have kira carbon, so you just have to identify the four different group attached to it. Okay, so this is actually how you classify the 4 groups that is bonded to the second carbon. Okay, so if I highlight here, this is the first carbon, second carbon, third carbon, and fourth carbon. So you can say that structure B can form enantiomers. Since it has kira carbon. So I can say that it is optically active. Okay, since it has kira carbon. Okay, so that is all. You can proceed to the rest of the question.